Thanks for the introduction, Joern Ploennigs. Hello. I want to talk about building foundation models, which is a little bit like a review paper on what can we actually do, should we do with LLMs and LVMs in our domain, and is it always a smart idea to use them? We see in the conference, of course, like many people are using them, everybody's excited, right? So, but basically the same second questions to each of the presentations is like, what do you do about hallucinations? Right, so that is a little bit like one of the aspects that we're investigating here. So what we kindly did is we did a review basically on publications in our field, civil engineering, but also in computer science. So really get to the ground truths of like what LLMs and LVMs actually are capable of, right? So, and then analyze a little bit like, okay, good, what are their strengths? Particularly in our field, right? So, but particularly also what are the potential weaknesses we need to be aware of when we excitingly use them for our work, right? So, and from that, then we condense additional like research directions, aspects where we think as authors, but we also hope you as community can agree to those points we need to work on in future and particular together. Right, so that is one of the main aspects here. And then on the end of the day, like I'm talking briefly a little bit like about the potential use cases. So we all know LLMs, LVMs have great potential. Every time I need a nice poem about something, the LLM can generate me one, right? So the unfortunate situation is in civil engineering, right? A bridge is not a poem. Right, so, and the outcome of like a bridge that is generated by generative models might not be, might have some disastrous consequences that are not as critical as a badly written poem, right? So, and that is a little bit like one of the aspects that we need to be aware of. So what are LLMs or LVMs in general good at? So the first thing is, yes, of course, they can generate. Right, so that's what they are, or why they are called generative AI systems, right? So the other aspect, more interesting aspect actually is they can summarize, because that was the original things why they were created, right? So to summarize large amounts of text, large amount of images, and kind of like describe them, right? So that is one of the main capabilities they also have, and we have seen a lot of applications, that directions in the conferences where people use that for classification tasks, summarization tasks, extraction tasks, exactly their purpose in that dimension, right? So the last important direction where they are very useful is like adaptation. You can easily tune them to your domain problem, right? So when you have a specific data set, right, so you either tune them by like context injection, right? So, or you kind of tune them actually by tuning the model itself, right? So both are like capabilities, which is called like this short-term learning, or that is basically one of the aspects there, right? So. Now, the reality is, like in civil engineering, we also have to be aware of that is not always working like nicely, right? So, and we see that also like every time who works with that, or everybody who works with that sees they also tend to fail, because in the end of the day, there are probabilistic systems and probabilistic models, right? So and when you try to understand like how an LLM works or how an image model works, it quickly explains some shortcomings they have. First of all, yes, they hallucinate because they are trained on providing an answer. They are not aware when they don't really know facts, right? So, but they still try to satisfy you based on the probability distributions that they have learned, right? So to give you any kind of answer, because that's what they are trained on, right? So it's like a student who didn't learn for his exam, right? So he still gives an answer, might not be the right one. The other problem is we have in our domain, and we see that as well, right? So they don't really understand BIM models. Yes, you can upload a step file. Yes, you can extract facts from BIM and upload to the LLM, but they do not really understand the geometry of any kind of CAD and BIM files, because they don't have spatial understanding. They don't really have an understanding of like what is space, what is time, what then is causality. So you either tell them or they will not understand it, right? So, and that is one of the aspects we also have to work on, right? So, and the other aspect is, which we kind of can fix a little bit like with tuning, is they don't really have a good understanding or generalized knowledge of our domain, right? So yes, you can use some of the larger models, right? So which also understand some concepts of civil engineering, but when you have a very specific project settings, they will not know all the norms that you need to be aware of in your specific project setting, right? So that are like some of these typical problems. And then the day, what this all sums up to is, I would be careful in using them in any kind of practical setting, right? So because we can't really trust their results in our applications, particularly then later in practice, because there will be the cases where people just use them and then say, but the AI told me I should do that. Nobody told me that I also start thinking on my own, right? So, and that is a significant problem, of course, in civil engineering, because we are building critical infrastructure that simply has to work for 30, 50 years. Now the question is, what can we do about it, right? So, and what are actually the aspects that we really have to work on from our perspective together in a community, right? So the first thing is, and we already had that discussion like yesterday and in some of the sessions, right? So we need to start collecting larger data sets. It's fantastic that everybody of us is starting doing and working on their own data sets, but truth be told, we're talking here about large models, right? So it is not sufficient that we just have these small benchmark models or data sets. We need large ones that actually contain the different test cases from different perspectives, that we actually can really validate those models on these large data sets and also use those large data sets for training better domain-specific models. Right? So because that is what we in the end of the day really need, right? And we can't just hope that this generalized AI models that we currently have simply solve that problem at some point in the future. And yes, depending on what the modalities that we have, and it's changing, right? So the capability of these models in interpreting these different data formats changes, right? So yes, they're good at text, for example. They are good at describing pictures, extracting text from pictures. They are good extracting text from step files, right? So, but like I said, they don't really have spatial understanding, and they don't really have tabular understanding. They don't really have causal understanding when it gets too complex. So in all these aspects, they will fail because it's not in their current structure to solve those problems. So that simply means we need to work on better models as a next step. Right? So once we have larger training data sets, we can develop our own models. And when we start doing that, we have to think beyond just doing RAG, to be honest, right? So because RAG is not sufficient, will not solve our problems, because it's not just about looking up some text or looking up some subgraphs in a graph and hoping that this explains how a building is constructed, right? So it will not. Right, so because a building construction or an infrastructure structure is way much more complex than just some graph patterns. And we need ways to train those models on these structures that we then can explain those structures, extract those structures, and yes, also generate those structures in future when we have our own generative models for BIM models at the end of the day. And last but not least, when we really want to make that a success, well, we need to think beyond just the research aspect. We need to think about how do we actually integrate that in practice? How can we actually make those build tools that make it as easy to as possible to use and integrate in the current workflows? Right? So because what we want to get to is that people use these tools and save time. This means, it doesn't mean I change into another tool, I start converting data, I kindly copy stuff overnight. It needs to be integrated nicely into the existing workflow, such that in the end of the day, when I'm in my CAD tool, that I just get recommendations doing my design on what do I do right, what do I do wrong, how can I improve my model. This is how it needs to be working at the end. And of course, it needs to be working for the different users. So where do we get to when we realize all of that? So first, of course, we might get to a position where we are able to automate design steps at the beginning, right? So meaning you just write down, and this starts with requirement engineering, right? So you need take all the documentations you have about your construction site, all the historical information, that is distributed in the documents, that is distributed in regulations, that is distributed in GIS systems, and you kindly extract the most valuable information, and the AI model extracts the constraints for then generating designs that actually address those constraints, right? So then, of course, for that, we need to be able to extract all the standards and regulations that we currently have and make them not just accessible to the AI systems, but honestly also to us as user, because nobody really knows all the standards that are relevant in a specific field. Then, of course, like during the build stage, right, so we also can use AI, right? So because then we take those models that we generated and we can explain those models, right? So when you're on the construction side, right, so an important problem we all know is just monitoring progress, just basically understanding what is currently going on. And yes, LVMs are good at interpreting images, right? So LLMs are good at extracting and analyzing text. So we can analyze and extract information from the conversations that goes on our construction site and around our construction site, right? So, and bring that together in one project-specific model that really can answer questions to that project and really help me solving issues that occur daily on a construction site, right? So, and then of course another aspect is, and we all know that, right? So construction nowadays is an international business, so they also can translate that into different languages. So next thing is an operation, right? So this is about just guiding the users in better using fixing problems. So they don't need to read through handbooks anymore, right? So you just tell them what are the most important steps to fix a problem in your system, right? So that's one of the aspects. And then last but not least, when we go to the recycling stage, you need to understand and extract what are actually the materials that are used in my building and extract that from the existing documentations as whatever it is, right? So, and that is important aspect. So this is a call for action, right? So yes, they are useful, yes, and we should use them, but we are not there yet, right? So we should not close our eyes for the problems that those models actually have at the moment. We rather should work together to improve those models, and this means let's collect larger data sets, let's work together on bigger, better models, because we only can do that together, right? So, and then let's work on tools that really integrate that. So this is a call for action. So happy to everybody's question on the one hand, and also when people want to join, just approach me.